This session discuss the extended surface is also called as fins. The heat conducted through solids, walls or boundaries has to be continuously dissipated to the surroundings or environment to maintain the system in a steady state condition. In many engineering applications, large quantity of heat have to be dissipated from the small areas. Heat transfer by means of conduction, convection or radiation can be considered. Heat transfer by convection between a surface and the fluid surrounding it can be increased by attaching the surface thin strip of metals in general called as fins. These fins increase the effective area of a surface, thereby increasing the heat transfer by convection. So these fins are also called as extended surfaces. Here you can see some of the schematics of the variety of fins. The ribs attached along the length of the tube is called as longitudinal fin. Here you can see a pipe where a strip of metals which will be fixed along the length of the tube is called as longitudinal fin. This is especially called as external longitudinal fin. And here you can see something which is similar type internally. This is called as internal longitudinal fin. It's called as internal longitudinal fin. And the next and the second kind of fins we call it as circumferential fins, where the concentric annular disc around the tubes is called as circumferential fins. For the typical two-wheelers exist this kind of fins. You can see either people are using two-wheelers, this kind of fins are explicitly visible. And third type of fin is called as pin fins. Pin fin. This is called a pin fin. Also called as spines. A small rods protruding from the surface is called as pin fins. The last type of fins is called as plate fins. It's like a small plates of varying cross section like rectangular, triangular, which will be protruding from the surface is called as plate fins. So these four kinds of fins are exist in various applications of engineering where heat transfer exists. Now the question is to calculate the temperature distribution of the fins and also the how much amount of heat transfer. Now let us see the first type of fin is called as rectangular plate fin of uniform cross section. Here you can see the rectangular plate fin of uniform cross section. So consider a small element, a small strip whose thickness will be dx and heat entering is qx and heat leaving is qx plus dx, whose thickness will be t and area will be a and width of the pin will be w and the length of the fin will be taken as L. So the temperature distribution is expressed by the formula T minus T infinity divided by T naught minus T infinity, where T naught is the base temperature, where T is the temperature at which we want to find out, and T infinity is the atmospheric temperature, and E equal to minus m into x. where m is constant, which is equal to square root of hp by Ka, where h is nothing but the heat transfer coefficient and P is the perimeter and K is thermal conductivity and A is the heat transfer area. Now the second one is to calculate the heat transfer. Heat transfer Q is equal to, we have a formula mKa into theta naught into e power minus mx, which is equal to mKa theta naught, which is equal to square root of hpKa into theta naught, which is equal to square root of hpKa into T naught minus T infinity, where T naught is the base temperature and T infinity is the environment atmospheric temperature, H heat transfer coefficient, P perimeter, K thermal conductivity and A is the heat transfer area. So with these two equations, it is quite interesting to calculate the temperature distribution of the rectangular fin as well as the heat transfer coefficient, where the convection mode of heat transfer exists between the surface to the environment. And for the second type of fin is fin with insulated end, where we have a temperature distribution T minus T infinity divided by T naught minus T infinity equal to cos h m L by x divided by cos h ml. And the heat transfer Q equal to square root of hpKa into theta naught into tan h ml. And the third kind of fin is called as convection of the end, where the temperature distribution is expressed by the formula theta by theta naught equal to cos h mlx plus h by mk into sin h m into L minus x and cos h ml plus h by mk into sin h ml. And the heat transfer Q equal to square root of hpKa theta naught into tan h ml plus h by mk and whole divided by 1 plus h by mk into tan h ml.